When scaling figures by ratio, it's very important to remember how ratios can also be equivalent ratios. In this example, I have 1 black marble for every 2 white marbles. So I could write that ratio as a 1 to 2 ratio, 1 black for every 2 white. But if I were to add 1 more black marble, in order to keep this ratio, I would have to add 2 white marbles. But now when we look at this, I can see I have 2 black marbles and I have 4 white marbles. But I kept the same ratio of 1 to 2, but I have 2 black and 4 white. This means that I have what we call equivalent ratios, and this is fine. This is called a simpler ratio than this one, because I can simplify 2/4 to a simpler one of just 1 to 2. That's because these can, what we call, scale up by multiplying the black marbles by 2 and the white marbles also by 2, the exact same number. If I can multiply or divide both numbers in one ratio by the same number and get the other ratio like this, that means they are equivalent ratios. Let's look at this example now with these 2 blocks. So this is a figure scaled up to this figure. But when I look at the side on this figure, it's 2, and the same side on the larger figure, it's 4. That we can say is a 2 to 4 ratio. This ratio describes how one block became the other block, whereas originally it was 2, it became 4. That means every 2 on one block became 4 on the other larger block. That means we could describe this relationship as a 2 to 4 ratio. But if I were to divide both of these numbers by the same number, let's say 2, since they're both divisible by 2, that means that I could actually change this into a smaller ratio of 1 to 2. This is okay because this is a simpler ratio that describes the relationship between these 2 figures. Even though I could say it's a 2 to 4 ratio, I could also say it's a 1 to 2 ratio. That means, well, this has 2 blocks going this way. I have 4 blocks going this way. That means for every 1 block here, there is 2 blocks here. And here's another block, and here's another 2 blocks. This means I can see my simplest ratio, 1 to 2, in the sides that are 2 to 4. Just like I can see my simplest ratio, 1 to 2, in my larger example of 2 marbles for every 4. So, let's look at one more example. Let's say I had a ratio of 4 to 7 that describes how I scaled one square into another square, where on the original one the side was 8, but I don't know the length of the other side. That's okay, because I can write a new ratio using 8 exactly from that side right over here. I'm just going to use my original ratio of 4 to 7 to figure out what my missing value is by writing an equivalent ratio and solving for that equivalent ratio. So for this one, I'm going to look at my simpler ratio and think, what times 4 will equal 8? Well, I know that times 2 will give me 8. So that means I could take my 7 and I can multiply that by 2 as well. That will give me 14. That means that 14 is over here as my length is 14. So what I've done here is I've actually written a new ratio that's equivalent to my original one of 4 to 7. Only my new ratio uses the actual lengths of 8 on one figure and 14 on the other figure. That's just using the actual lengths. It is equivalent to the original ratio of 4 to 7. That means it describes that for every 4 blocks on one, there are 7 blocks on the other. But I could also say for every 8 blocks on one, there are 14 blocks on the other. I'm using blocks in this case just to count the lengths of the sides. And that's why I've drawn these. But you can see in this example that I can take a section of that 8 and see 4. And I could take a section of the 14 and see 7. And I'll see my original ratio of 4 to 7 inside my equivalent ratio, exactly the same as 8 to 14. I know they are equivalent ratios because I can just multiply the 7 and the 4 by 2 and I will get my other ratio. So in conclusion, I can find any equivalent ratio by multiplying the numbers in one ratio by the same number, or dividing each of those numbers by the same number and get a different ratio. And whichever ratio is easier for me to use to find the missing length of a side on a figure that's been scaled up or scaled down, that's the one I use. This 8 to 14 is easier for me to see that 8 becomes 14 than 4 to 7, so that's why I used it.